Hey guys, I'm back here with electronic configuration and electronic distribution concept. In the last video, I have just started this concept of electronic configuration and electronic distribution. Now, point number one is this, that what is electronic distribution or electronic configuration? Okay, let's see. Let's see here first. For example, we are saying that nucleus is in the center. Okay, nucleus is in the center, and around the nucleus we have electronic shells. All right, these are the pathways, these are the electronic shells in which electrons are revolving. Okay, now these electronic shells have specific names. Okay, what are those specific names? We have just said that one of them is K, the other is L. Okay, which one is K? Now the point is this, which one is K? This is K, this is L, this is M, and definitely the outer will be N. Okay, I'm drawing the N as well so that there may not be any confusion. Okay, so the last shell is N. Okay. Now the point is this, that how we are going to fill the electrons, what is the capacity, what is the stability level of every shell. For example, the room in which you are sitting right now might have 20 seats currently. Okay. So how many people can be seated over there? 20 people can be adjusted over there, can be seated over there. Okay. So that room can accommodate 20 people. So if we are talking about these shells, they have specific seats, they have specific number of seats, and they can accommodate a specific number of electrons. Okay. So right now, this K shell, this is the first shell. First shell means this is just after around the nucleus. Okay. So this first shell can have accommodation. It can accommodate how many electrons? Two electrons. So there is a term we can say that K shell is full, or you may say completely filled if it is accommodating two electrons. But if there is one electron in the K shell, we can say that K shell is accommodating one electron. Accommodating one electron, it means that K shell is half filled. But now, for example, if we are moving to L shell, which is the second shell, what is the capacity of the L shell? It can accommodate 8 electrons. All right. So 8 electrons can be accommodated in the L shell. But if there is, for example, 4 electrons in the L shell, we can say that L shell is half filled. For example, if there are 2 electrons in the L shell, we can say this thing that L shell is in the process of filling. If there are 6 electrons in the L shell or 7 electrons in the L shell, we can say that L shell is in the process of filling. But for example, if there are 8 electrons in the L shell, we can say that L shell is completely filled. But if there are 4 electrons in the L shell, we can say that L shell is half filled. Okay, so first of all, we will start filling the electrons in the K shell, where we are going to place 2 electrons. Then we will move to L shell, there we are going to place 8 electrons. Then we will move to M shell. M shell has the total capacity of 18 electrons. Okay, M shell is a bigger room. We can see this thing that M shell can accommodate 18 electrons. So how many seats are there? There are total 18 seats on which 18 electrons can be seated. Okay, but M shell will be happier if we are placing 8 electrons in M shell. Okay, so first of all, how many electrons we are going to place in K shell? 2. Now many of the students might be thinking that, is this a rule? Do we need to follow this rule always? Yes, this is the rule of filling the electrons in the electronic shells, and we have to fulfill this rule always. There will be an advanced type of electronic configuration waiting for you in AS chemistry, but right now this is the electronic configuration for IGCSEs and for GCEs as well. Okay, now what is the rule? We are going to revise this whole thing. So first of all, we are going to place 2 electrons in the K shell. Then we will move to 8 electrons in the L shell. Then we will move to M shell. How many electrons we are going to fill up there? 8 electrons first. What is the total space available? Total space in the M shell available is 18. But how many electrons we are going to fill in the M shell first? We are going to fill 8 electrons first. And then after filling 8 electrons, we will move to N now. Okay. Yes, we are not going to pursue it to 18, but we will move to N after N for nose. After filling 8 electrons in the M for monkey, we will move to N for nose. And how many electrons we can fill there? 8. Okay. How many electrons we can fill there is the answer 32. So what is the capacity? How many seats for electrons are there in the N shell? As the size is quite huge, so you can see this thing that it can accommodate how many electrons? 32 electrons. But how many electrons we have to fill up first? We have to fill up how many electrons? 8 first. And then where we are we are going back to M. Okay, so first of all, it is K 2, then L 8, then M 8, then N 8, then back to M. And how many electrons in the M now? We are going to add up 10 more electrons to the previously present 8 electrons to make it 18. Okay, and then after completing this M shell to 18, we will now back to N shell. And how many electrons we are going to fill up there? There we are going to fill up till 32. Now I'm repeating the whole concept. Okay. First of all, we will fill how many electrons in the K shell? 2. Then we will go to L. Here we are going to fill 8 electrons. Then we will move to M. How many electrons? 8. Then we will move to N. How many electrons? 8. Back to M. How many electrons? 10 more to make this 8 into 18. And then back to N, and then fulfill this N shell, and turn this 8 into 32. And we will keep on adding, and we will shift this 8 into 32. Okay, I am now going to change the board, and I am now going to fill the electrons from hydrogen till calcium, so that you people may know this thing, that what is the electronic configuration of the first 20 elements. First 20 means the elements first 20 atomic number, the elements with first 20 proton number. Okay. Okay, guys, so you can see this thing, that this is now, let's see, we can mark it to half. Okay, and this is now this, so that you people may differentiate. 1, 2, this is 3, 4, 5, 6, 7. All right, great. Okay, so this is now hydrogen, and here I'm going to place the remaining. Okay, so you can see hydrogen, its atomic number is 1. So what will be the electronic configuration? 1. Helium, it is 2. Okay, and instead of doing this, I would like to do another line over there. We can take a different color, for example, blue. All right, and here we are going to place another line. All right, okay, so there I'm making 2 lines. All right, okay, so it is hydrogen 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this is the atomic number here. Atomic number. Okay, atomic number, or you may consider it electron number. Okay, so it is hydrogen, helium, lithium, this is beryllium, this is boron, this is carbon, nitrogen, this is oxygen, fluorine. Fluorine is not Fl, bache. I am telling it to you continuously. So this is number 10, that is called neon. And now we are moving to 11, 12, 13, 14, 15, 16, 17, 18, 19, 20th. Okay, so we can see neon, and then we are moving to number 11, that is called sodium. This is number 12, and this is magnesium. This is aluminum. This is silicon. This is phosphorus. This is sulfur. This is chlorine. This is argon. And this is potassium. And whereas this is calcium. Okay, let's fill the electrons. Okay, I'm taking some other color. We can take, which color we can take? Okay, let's take white. Okay, so for example, there are how many electrons with hydrogen? 1. And we can say this thing, that K shell is half filled. Okay, so here I'm writing K half filled. How many electrons we can fill in K? 2 electrons. But here, as only 1 electron is filled in case of hydrogen, so it is half filled. Okay, now move to the helium, and that is called number 2, and this is okay. Number two, okay. So we can say helium has how many electrons? Two electrons, and we have filled it in the K shell, okay. I'm going to make a star over here. Why? Because K is completely filled, okay. So here I'm mentioning it with an other shade, okay. And what is this? We can take this. And this is helium. And why it is with another shade? Because it has how many electrons? Two, and it is the K filled. K full shell, okay, full, okay. So that's why K is full. So that's why we can say that it has a star. Why? Because it has reached the complete electronic configuration for K shell, okay. In case of lithium, now how many electrons are there? Three. So where we are going to fill the electrons? First we are going to fill two electrons in K, and then we will move to one electron in L, okay. So L shell is started from lithium, okay. Move to beryllium. So now it is 2 in the K and 2 in L. So 2 in the K, 3 in L, 2 in the K, 4 in L, 2 in the K, 5 in L, 2 in the K, 6 in L, 2 in the K, 7 in L, 2 in the K, 8 is L. So there are 8 electrons in the outermost shell of neon, and we can see that L is completely filled here, okay? L is complete here, okay. L is complete, L is filled, and whereas K was full in case of helium, and we have made a star with helium as well, okay. And what is the star level? Here I'm going to tell it to you, that here we can see that it is completely filled, and that's why it is having this star, okay. So right now I am changing the line, and now I am with sodium. Okay. Now you can see this thing, that 2 in the first shell, 8 in the K, 2 in the K, 8 in the L, and then 1 in the M. So can we say this thing that M started here? Okay. M starts here. Okay. Okay. Whereas with lithium, we can write L starts. All right. And then what about our magnesium? It is 282. It is 283. It is 284. It is 285. It is 286. It is 287. It is 288. Okay, now I'm going to explain this thing to you. What is the meaning of 284? Means 2 electrons in the K shell, 8 electrons in the L shell, whereas 4 electrons in the M shell. M stands for monkey. Okay. Well, what about argon now? Look at here. 2 in the K shell, 8 in the L shell, whereas 8 in the M shell. So can we say this thing that M has one stability level? M was feeling happy when there were how many electrons? 8. Okay. 8. So that's why can we say this thing that in case of argon, M has reached its happy destination. M has reached its stabilized electronic configuration. So M was stabilized at 8 or at 18. M has a complete availability of 18 seats, but M was feeling happy when it has 8 electrons as well. So in case of argon, it is again the stabilized electronic configuration. So that's why there is a star as well. So what is the reason for this star? Because here you can say that in case of argon, the M shell is reached at its stability level. Okay. Now we are moving to the K, or this K for potassium. Okay. Now it has total 19 electron numbers. So 2 in the K, 8 in the L, 8 in the M, and then 1 in the N. Okay, yes, we have to fill 2K, 8L, and then 8 in M. After filling 8 electrons in M, we will move to N. We will continue filling electrons in N for nose till 8 electrons, and then we will back to M. But here, as in your syllabus, till 20 is required. So that's why we are keep ourselves till, that's why we will keep ourselves till 20. So here in case of calcium, can we say this thing here in K, that here N starts, okay? N starts here. Whereas what about for calcium? So it will be 2, 8, 8, 2, okay? So this is the basic concept related to electronic configuration. You people should know this thing, that how to write down the electronic configuration. Before this, in this lecture, that previous lecture, I have told you that how to calculate the neutron number. This is very, very important because examiner is asking this thing, that how to calculate the neutron number from the given nucleon number and proton number. I have told you about this formula at the top, and then we have studied this deviation wala concept. And now today in this lecture we have discussed this thing, that what is electronic shells. These are the pathways around the nucleus in which electrons are present. Electronic shell, a detailed definition, a complete, a more comprehensive definition is waiting for you in AS, but right now it is unfair to tell you that definition. So these are just the pathways, these are just the places in which electrons are revolving around the nucleus. The smaller the size, the lesser will be the available spaces, the lesser will be the capacity to accommodate the electrons. The larger the size, the higher will be the capacity to accommodate the greater number of electrons. So that's why N stands for nose, has a greater space, and that's why it is accommodating more number of electrons, that is 32. And this first shell, which is K, and that is accommodating only 2 electrons. Might be some of you are thinking that these names are specific. Yes, these names are specific. Instead of giving A, B, C, D, or giving W, X, Y, Z, the axis we are using for to tell the x-axis, y-axis, z-axis for different type of things in the space. So it is convenient for the scientists to take such type of alphabets which are not used anywhere. So this is K, L, M, N. So there is no logic behind that. So please be careful about that as well, and don't get upset, and don't give more attention to this concept. Okay, so this is requiring only this much attention, that K, L, M, N is the name, are the names of the shells, and they are accommodating specific number of electrons, and how to fill the electrons in these shells. That's it. And we have practiced for this. It will be my advice to all of you to make a practice of writing. Okay, and then you people can listen this lecture carefully again, so that things can become much more clearer to you. If there will be any query or a question related to this, most welcome. You may send me the question in the YouTube comment and etc. I will definitely back to that. All right, and in the next lecture, inshallah, I will pursue with the concept of isotopes. Here I am writing the heading. It is isotopes. What are isotopes, and details? Isotopes. All right. So we are going to discuss this concept of isotopes, inshallah, in the next lecture. Thank you very much. Take care of yourself.